Thanks everyone for joining. Today's webinar will be about graphs in retail. We're going to do a brief introduction to graphs and Neo4j for anyone who's joining who's not already familiar with graph databases and with Neo4j's graph database. Then we'll take a look at some typical data that a retail company might have across their organization. From there, we'll dive into a few specific use cases. So we'll start with Customer 360, which then feeds into recommendations. When we talk about recommendations, we'll do a live demo as well. So we'll see a recommendation system in action. We'll then talk about supply chain management, and we'll touch on a few other industry agnostic type of use cases that might be applicable in retail as well. And then at the end, we'll answer as many questions as we can during a Q&A. So to start, an introduction to graphs and Neo4j. So most people are familiar with SQL databases. SQL databases are tables. It's like Excel. You have rows. Every row has a number of columns. You put data into that. You use SQL to pull those tables out. Very tabular format, quite structured data. And you have to do joins between tables to be able to link together different entities. The graph database model is pretty different. So in graphs, you focus on the connections between data, and you organize your data, from the disk all the way up as entities and the relationships between them. So it's designed for working with highly connected, very complex data sets with a lot of relationships. Instead of SQL with Neo4j, you use a language called Cypher. And you can see a little example of it down there. It's a language specifically designed for working with graphs and connected data. So the benefits of working with connected data are many, and now we're starting to see as data grows, the complexity of data grows, the number of sources of data grows, how important it is to leverage the connections between your data and the context that gives you. So it's the next wave of competitive advantage, really, and we're already starting to see this, will be about using connections. And if you look at some of the big early movers and shakers that defined the internet age, LinkedIn, Twitter, Facebook, Google, all of these use graphs to power their technologies and their services. And the great thing about it is, often, if you're an organization that's been around for quite a while, you'll have a number of different data silos, different systems in which data lives. So your customer data could be in CRM system. You might have third-party data, market data, another system that holds your product data. So being able to combine all that data, link all that data, and understand the relationships between it across all those systems gives you a really powerful view across your business that you can't really get when you approach your data in a siloed way. So Neo4j, who are we? We are the #1 database for connected data. We've been around for quite a while, kind of created this database genre, really. We're also #1 in terms of production installs, customer base, overall user base. So Neo4j is an enterprise-grade native graph database, which means we're designed explicitly for graphs. As I said, it's graphs all the way up, graphs from the file system up. So it's not a layer on top of another database type. It's not something designed to do many things at once. It's not multi-model. It's specifically designed for graphs. So we can leverage the power of that architecture, that graph paradigm. For our high performance, we're ACID compliant. So that means when you get your data into the database, you can trust it's going to be there. Your data won't be corrupted. It's got security built in, developer tools, scalability, all the things you would expect of an enterprise-grade database, to work in a live production retail environment. So to give you a bit of a taste of what the graph looks like before we dive into some of the examples, the graph database model is made up of 3 different things. There are nodes, so that's what we see here as circles. They represent objects or entities in the world. Usually they're nouns, and they have labels. So this is just a way of kind of tagging the object, labeling it to make it easier to query and work with. So here we have 2 types of nodes, 2 node labels. We have persons at the top, and we have a car at the bottom. Nodes can have properties. So here we see the node, the person node in the upper left. His name is Dan. He was born May 29th, 1970. We have his Twitter handle @Dan. So those are just key value pairs, properties that you attach descriptively to a node. The person on the right, her name is Anne. She was born December 5th, 1975. We don't have her Twitter handle, and that's okay. Having a label doesn't necessarily imply a schema. It's not like a relational database where every row has the same number of columns, and if there's no data in that column, you have to put in a null. Neo4j out of the box is a little bit more flexible and allows you to have different kinds of data. So it makes it very easy to evolve as more data becomes available, as new data sources come online, to be able to add that data over time and iterate your data model. There are ways, though, to enforce schema if that's important for your use case. Lastly, we have relationships. So relationships are what link entities together and what really give the graph model its power. So you can see the person on the left, Dan, lives with the person on the right, Anne. And every relationship, when it's saved in Neo4j, has a direction. So that relationship goes from left to right. But it's kind of logically impossible for Anne not to live with Dan if that's true. So we don't need a relationship going in the other way. We could ignore the direction at query time and just say, does Anne live with Dan? Does Dan live with Anne? It doesn't really matter. However, sometimes the direction is more important. So we see that here with our example, loves. It would be possible for Dan to love Anne, but for Anne not to love Dan back. So here, luckily for Dan, Anne does love him, but we need the relationship in both directions because love, the direction of that relationship is very important. And then you can see you can also have properties on relationships as well. So Anne owns the Volvo and Dan drives it. He has since January 10th, 2011. So those few components really give the graph its power, give us everything we need to be able to model really complex data sets and take advantage of the relationships between entities in a way that's really difficult with any other type of database. Okay, so we'll take a look now at an overview of the types of data that a retail company might have so that we can talk about how we can build graphs from that data to drive different use cases. So first, we have organizational data. So this is data about your company, documentation you may have internally, processes you may have internally, information about your facilities. Maybe these are warehouses, maybe they're factories, maybe they're retail stores, the places where your business operates. You have organizational hierarchy and kind of information about the people that work for you and the departments and how those are structured. KPIs and reports, obviously, this is the information you use to drive your business and make important business decisions. And then you have systems and databases, so your IT architecture, your IT structure, and kind of where things live, where data might live. Then you'll probably have some product data. So you might have information about brands, either your brands or brands that you sell, product hierarchies. So maybe within a brand, there's several layers of kind of product groupings and product lines. Data about pricing, how you come up with pricing, how things are priced, what things are priced, promotions, so on. You might have documentation about individual products, maybe that you need to provide to your customers through a search engine. And then there might be processes associated with certain products, how they're sold, how they're supported, how their warranties work, and so on. Then there's some customer data. So of course you'll have information about your customers, their name, where they live, maybe some financial details, some information that allows you to segment them according to kind of various aspects of their profile. Then you'll have purchase history. So what have they bought from you before? If you're a brick and mortar store, you might keep track of this through a loyalty card. And then of course for e-commerce or online retailers, it's easy to track what people have bought through their account history. And then really interestingly, you might have some information about the relationships between your customers. So maybe you know customers are married or family members. Maybe you have a social aspect to your business and you know who are friends of who. So being able to bring in these relationships when you're looking at customer views and making recommendations can also be really very useful. Event data. These are kind of individual events, things that happen. So here we've listed a few. E-commerce sites might have clickstream data. What did people click? What did people view? What did people search for? When did people contact you, and what was the result of that customer contact? Third-party data. So I've called this local data. Often it can be quite interesting to bring in weather data, information about what's happening in a particular area. Is there a sporting game or a big event or something like this that you can combine with the rest of your data to make decisions about promotions or what to recommend to an individual. Of course, social media. If you can process Twitter feeds about your company or what people are posting on Facebook and how they're interacting with your various social media entities, that's very interesting to combine with the rest of your customer data. And then of course market data, what's going on in the market, what's popular, what's happening to the companies you work with in terms of their business. And finally, supply chain data. So you'll have information about your suppliers. Where do you get your supplies, your goods, your raw resources? Logistics, how are things shipped? And information about your inventory. So what do you have in stock and where? So from this sorts of data, and of course it's not an exhaustive list, there's other types of data that might exist in retail as well. But from some of those different components we just talked about, we can put together some example graphs to illustrate how you could use a graph and your data to power specific use cases in a retail environment. So first, we'll take a look at Customer 360. So this is the idea that you have access to all the information about your customer that you know. You can access that holistic view, maybe when you're interacting with your customer, when you're making decisions about recommendations or promotions, being able to see everything you know about a customer at once is really powerful. So here you can see in the middle, we have our customer. And around that, we have a number of relationships, right? And we can see on the right-hand side here, we've got the same colors and the same types of data that we talked about on the previous slide. So that's how we're grouping everything together so we can make sense of what's going on. So we have a lot of information about a customer in blue, right? Makes sense if it's Customer 360. So we might have some segmentation information. If we've done some community detection, run some segmentation algorithms, classified a customer in a certain way, then we'll know what segments they belong to and how we might be able to approach them based on that. Of course, you can use the graph to support that segmentation. There are graph algorithms for community detection that run natively on Neo4j. It's part of a free package of graph algorithms that we've written and published. So you can do community detection on your graph based on what things are connected to, right? So it can be a really powerful way of extending your existing segmentation. And then we have contact details and contact preferences. So this is really important, of course, in the context of GDPR and a lot of other data privacy initiatives. Not only do you have information about how you can contact your customers, their address, their phone number, their email, you have to know how they want you to approach them and when. So do they want marketing? Do they want email? Do they prefer SMS? And so on and so forth. We have some address information. So this customer ships to 2 addresses, maybe a home and work address. And we can see they're also related to another customer who's a family member of theirs, and it ships to the same address. So you can start to infer, even if you don't explicitly know that someone is a family member of someone else, you can start to infer types of relationships from the graph, right? So if we know these 2 people shop at the same address, based on what else you know about them, you might be able to infer, are they partners, are they roommates, or at least they know each other, and you can connect them in the graph and look at them, look at that relationship. We have the similar here with friend. And then we get into shopping basket information, who's bought what. So you can see the customer has a number of shopping baskets that they've bought. There's some SKUs that were in there. There was a promotion on one of them. We also know this customer tweeted about that SKU, about that product that they bought. So we're starting to see kind of an interesting pattern where they've bought something that was on a promotion, they then tweeted about it. And we can also see there's two support contacts about that product related to that order. So maybe we would need to know if that tweet was positive or negative. Look at the results of that support contact to understand, if there's anything else we need to do in this situation, or if there's something about this product maybe that would need to be addressed, if there's a pattern of this sort of behavior. Then we can see there's some interesting stuff going on here as well. So from another one of their shopping baskets, that customer bought this SKU. They also rated it and they had searched for it. So sounds like this customer really kind of wanted to buy this and could have been fairly happy with it. And then we see their friend and their family member also had shopping baskets. And those shopping baskets also had that SKU. So it would be interesting to know if there was an order that this happened in. Did the friend and the family member buy that item after the customer did, after it was rated? And then we can start to think about whether or not this customer might be an influencer, right? Did these people buy this product on the back of a recommendation from that particular customer? How many other people is that customer connected to? And then you can start to consider whether this is a really influential customer in your graph, whether you need to go above and beyond to make sure that they stay happy, maybe offer them special promotions, things like that. And then to wrap it up here in the upper left, we have some web channel information. So what did the customer view? What items were on those pages? So that we can, again, maybe think about, if they're looking for the same types of items maybe, but not putting anything in their basket, maybe it's time to send them a promotion for something along the lines of what they were looking at. And finally, we have a store location that customer visits. So, obviously, I think a real customer's graph would be probably more complex than this, and certainly have a lot of different data points, right? Maybe lots of shopping baskets, lots of promotions, but this, I think, gives a good idea of how you can, take a look at everything about your customer from all the different systems that it might be in, and that one holistic view, and what sorts of things you could then do with that data. So could you use that graph to improve customer experience? Absolutely. When you have access to all the information about a particular customer, when you're interacting with them, that gives you a lot of power. It gives you a lot of ways in which you can delight your customer. So you can follow up on open tickets. You can talk to them about, maybe, there's a special promotion you want to give them. So, maybe some extra rewards at a membership program. There's lots of ways that having that information can inform decisions you make about how you interact with your customer and make that interaction a better one for them. Can the graph help you determine customer lifetime value? Absolutely. So when you have that view of your customer's behavior, you can start to predict what they're likely to do. If you see a pattern of behavior, they buy certain things at a certain time of year, maybe that's birthday time. You can start to infer, do they have children or a partner? Do they splurge a lot at Christmas? Being able to predict what they're likely to do based on what they've done before can give you that view of customer lifetime value, and again, can inform decisions about how you interact with that customer. And conversely, can you spot and prevent churn using a graph? Yes. So as you start to identify patterns in the graph that lead up to churn events, right? A loss of a customer, things like first they bought something, then they tweeted about it, then they contacted support about it twice. When you can see that pattern of behavior, then you can predict who's likely to churn or who might churn as that pattern appears, and you can start to become proactive in preventing that churn rather than just analyzing it as a KPI after the fact. And finally, we talked about spotting influencers in your customer base. Absolutely, and again, the graph algorithms can be really handy here. If you know about connections between people, there are a number of centrality algorithms between the centrality and PageRank and things like this that can help you score people in your graph, entities in your graph, how central they are, how important they are in your graph. And then you can, again, start making decisions about how you treat those influencers and what extra value they might bring to your business. Next is recommendations, and this is a really big use case for graphs and for Neo4j. Some of it depends on a bit of that customer 360 view that we just talked about. So that informs this to a certain degree. We can see here again, we have our customer. We'll start by looking at a very typical, I think, way of approaching recommendations. Anyone who uses an e-commerce site will be quite familiar with this approach. So collaborative filtering, basically what we do is we take one customer, we take another customer, we compare what they had in common in their shopping baskets, right? So our customer here is browsing. They have a shopping basket with 3 things in it, but they haven't yet bought any. They haven't bought yet. They haven't paid. They haven't checked out. So if we want to make recommendations, what else they might want to add to their shopping basket, a very natural thing to do is say, other people who bought the things that are in your basket also bought these other things. Right? So here we see this other customer has a shopping basket with 2 things in common with our customer, and then 2 things not in common. So we could recommend those things that weren't in common as potentially interesting to our customer. To add to this, to add a bit more context, we can see that this customer has a family member who previously bought one of the items that our other customer also bought. So maybe that particular item that shares the relationship between this other customer and our family member is the most interesting thing that we could recommend. So we can add even more color to that. So what do we know about that SKU? What's our margin on it? What's the price that we present to the customer? What's its rating? Do lots of people like it? How many do we have in inventory? And what are the shipping options? So all of these things combined together can help inform how you rate things, how you order things in your recommendations, right? So if this particular item is high margin, is in a price range you think is reasonable for this particular customer, has a high rating, inventory looks good, maybe you have a lot of it and you'd be happy to get rid of some, and the shipping options align. It's not going to take 6 months to ship, then maybe this is a really good recommendation to make, right? So you can start not only taking those relationships between people into account, but also some of the details about individual items. And so you can make business decisions about prioritizing margin. Maybe, if you had a lot of inventory you want to shift, all of these things can come into play as you're making and ordering your recommendations. Additionally, we have some kind of product hierarchy information. So this item, the SKU is in a particular product line, which belongs to a particular brand. Maybe we have some external marketing information about these things. There's other SKUs that are in that product line. So starting to understand is this a popular item, right now? Are these companies doing really well? Or conversely, is there bad press about them in the news right now? Are they in trouble? Are these items becoming unpopular? All these things can be taken into account as well. Coming back to our customer and their shopping basket. So we can see there's some other information that we have. There's another item that's in there, and we can see we've got other SKUs it's related to. One, it's related by a completed buy relationship, and the other one is with frequently bought with. So these are additional ways of helping us understand what we might want to recommend. So if someone is buying a pillow, maybe they need a pillowcase, right? So the pillowcase would complete their purchase. Or if you're buying a television, maybe you need some additional HDMI cables. Your HDMI cables would complete your purchase so that you have everything you need. And of course, frequently bought with, again, might take the same approach. But you look at what things are bought together frequently. You can use machine learning offline, to calculate this, to understand what items are frequently bought with other ones, and then you can feed that into the graph, so that you know when someone is browsing or has added something to their carts, what other things people typically buy with that. We can see this customer has previously bought some other items, so you probably don't want to include those items in your recommendations to them, right? If they've already bought it and it's a big one-time purchase, you don't want to recommend a TV to someone a week after they bought a TV from you, right? It's kind of a waste of an opportunity and just not very clever. So we can, as we're starting to understand what things we might want to recommend using these other factors that we just talked about, we can start to understand also what have they previously bought and therefore what should we exclude, what do we not want to recommend. And then there's, segmentation information. So what items are popular with the customer segments that your customer belongs to. So for example, I'm a gamer. So, any retail organization I interact with would know that by the number of games I buy. And therefore, when a new game comes out, and that game skyrockets in popularity with other gamers, then that would be a wise recommendation to make to me. We can see what web pages this customer has viewed, what items were on those pages. So again, we can start to make recommendations about things they previously viewed but didn't buy. So if we can tell they were, looking into a stereo system to go with their new TV, but never bought one, that might be something we want to offer up to them. And then again, down here we have some social media activity, what do you know about your customer outside your direct interactions, and locality data. So where does this customer live? What's happening there? Is it the 1 week of the year when it's really sunny in London? And should you recommend sun cream to them? Is it skiing season? What have you? Being able to use local information about where your customer is to also inform those recommendations. So we're going to drill into a couple different types of recommendations specifically because this is such an important use case for retail. Right? So we've talked about product recommendations. When someone's looking at something, what else might they want to buy to be able to increase the size of their basket and their overall sale. There's promotions, which is similar in many ways, but quite distinct, although some companies are doing both, across multiple channels. So this is, maybe giving someone a coupon when they're leaving your store to entice them to come back, something that's relevant to what they've bought or what their interests are. Or maybe this is helping you to decide what to put on promotion in your store. So I heard an interesting story once. An analytics team was working for a retailer on the East Coast of the US, kind of the regional division of that retailer. And they were doing some analytics and they were trying to figure out, one of the questions they wanted to figure out was, what do we need to stock when there's a big weather event, when there's a hurricane? And of course, there's a number of things that are just completely obvious, right? Everyone needs water, everyone needs bread, batteries. There's kind of a set of things everyone knows you're going to need. But what is it that sells aside from that? And interestingly, what they found was that when you filtered out all those other things, the most popular items were beer and strawberry Pop-Tarts, which maybe makes a lot of sense. I don't know. But then they were able to put those things on promotion, get more of them in stock. So they use their data to recommend to them, what they should do in the case of this weather event, which I think is really interesting. And then finally, logistics. So how can you choose amongst all of your shipping options? What is the best route to get something to a customer? Right? And there might be a number of definitions for best. It could be shortest, it could be cheapest. It could be easiest. Being able to take all the information you have about logistics and about the route to your customer, and make an intelligent decision about how to ship goods to your customer. And of course, the really promising thing about this is being able to do it across channels, right? So being able to power recommendations for an app if you have one, being able to power recommendations on your website, being able to power recommendations in your brick and mortar stores, and being able to do that in real time across channels. So if someone's on your app 1 minute and they're on the website the next, you want to be able to carry over that context. You don't want to have to wait until tomorrow when you've done a batch import from a data warehouse, because then it's too late. You've missed the opportunity. So being able to do that in real time, live across channels, is something the graph would excel at. And Neo4j certainly already does in production scenarios. Not only do you need to do this across all your channels, you need to do it at scale. You need to do it for all your customers, right? Seamlessly, which is really the promise of the graph. So can you use the graph to improve sales with better recommendations? Absolutely. And we've seen this kind of time and time again, right? The better your recommendations, it's kind of self-explanatory that the better your sales you can expect to be. Can the graph help you make real-time recommendations across channels? Absolutely. Neo4j is designed as a real-time database. As I said, it's a kind of enterprise-grade asset database designed for these real-time scenarios. So, real time, not just in being able to respond with the recommendation in real time, the end user's experience of real time, but also being able to deal with the real time data, as I said, coming in across channels, and being able to make those connections and update the graph and gain that additional context in real time. Can you integrate your recommendations graph with AI or machine learning techniques? Absolutely. You can use the graph both as a data set to input into these sorts of tools, or as the place to store the output of them. So I mentioned before, frequently bought with, that sort of thing, being able to understand how often, being able to score how often things are bought with one another, understand those kind of behaviors between features, and then persist that in the graph, so that you can then use that to serve your real-time recommendations, because you can't do machine learning in real time. And can the graph help with other types of recommendations besides products? Yeah, so we already talked about logistics and how you can make recommendations there. There, recommendations for content. If someone is searching on your site, maybe looking for something about a particular product or a particular product line, being able to recommend to them the most appropriate documentation or the most appropriate part of your site for them to go to, the highest rated recommendations work in that sort of scenario as well. So now we'll take a look at a quick demo. Okay, so here what we see is kind of a representation of a retail site. We'll start with a clean slate. So we haven't added anything to our basket. We haven't looked at anything in particular. So these are just kind of generic sets of recommendations, right? Popular products and popular brands. So this is what you would get if someone just started at your site. You don't have any information about them. Maybe they haven't logged in, or if they haven't started browsing anything. If you don't have any basis at all for making recommendations, this is the minimum that you want to do. And the way we power this, so this is a Neo4j recommendations framework. What we do is build a few different engines for powering different sets of recommendations, right? So this lets you do the sort of thing we just saw. We have multiple rows or multiple areas for holding different kinds of recommendations. But it also lets you do things like A/B testing, where you can set up two variants of a particular recommendation approach, see which one does better, which one converts better, turn that one into your production one, maybe put another challenger up against it, and iterate that way by running different engines on different users and seeing what happens. So we can take a look, popular products. The way that the recommendation engine works, there's a few phases that you go through, and this is kind of quite logical in approaching recommendations. So first you start with a discover phase. Discovery is when you find the initial items that you want to recommend, right? So here, we don't have kind of real retail data, real purchase data, so we're mocking it up. Basically, you start by pulling back the nodes that you're interested in discovery. Then you go through the boost phase. So boost is when you start making decisions about reordering things, which should be the first recommendation, which should be the second, the third, based on some scoring criteria. So again, this might be margin. You want to boost things at a high margin. Maybe you want to boost things that are very high in stock. Maybe you want to boost things that are part of a particular promotion. There's any number of ways that you might choose to boost things that you found during your discovery phase. Then there's exclude. So there are things you might not want to show in your recommendations. So a good example would be like what I said before about excluding things that someone may have previously bought. If someone just bought a TV, you probably don't want TVs in your recommendation, so you can exclude particular items for different reasons. And then there's diversity phase. So diversity is when you kind of introduce a few different things, mix it up a little bit, introduce some serendipity to see if you can entice your customer to buy something maybe they're not looking at, something unrelated. And this could be a popular item. It could be particular things that you have on promotion and you really want to push, so you insert them 20% of the time into the recommendations list. Another good way to look at this is if someone is looking for a stereo, and you present them with 20 different stereos, it can be really hard to choose amongst those 20, right? You get overloaded by the choice, and therefore you kind of get frustrated with all the recommendations. So using serendipity, you can introduce different things to alleviate that, right? So maybe you only want to show 5 stereos, and then you show some related things, some other technology, things that are popular, what have you, to mix up your recommendations a little bit. So those are the 4 phases. Here we only have discover phase for popular products, and popular brands. What we do is our initial discovery, and then we boost based on popularity. So that's how we order the popular brands here. Okay, now if we take a look at some of these items, maybe we drill into one. So we can see here we have the details of this particular Canon lens, telephoto lens. We can see one of the ratings here. So someone gave this quite a high rating. Now we can see there's some different information here, right? So we can see products with similar categories. So these are items that are related to what we clicked on. You can see there's a lot of lenses and lens caps and things like that. Other users also liked. So these are things that the people who gave this 5 stars, other things they gave 5 stars to, or other things that they liked. Popular products, again, pretty much the same as we saw before, I think, and popular brands, right? So those haven't really changed. What has changed is that we now have products with similar categories and other users also liked, which is bringing in the context around this particular item that we looked at, and using that to drive a completely different set of recommendations. So we can take a look at the cipher for that. So similar categories is pretty straightforward. We find the categories that are in common between different items, and then we return them, and we also score them based on how many categories are in common. And collaborative filtering, this is what other people also liked. So here are things that other things that they bought. So people who bought the item you're looking at also bought this. What they also viewed. So you can see here where we're adding a score. So when we find the items that other people bought, that they bought at the same time as buying this one. We score that as 5, right? Because that's a pretty strong correlation. Other things those people viewed is a lower correlation, right? So we give that a score of 1. So it's interesting that people viewed other things when they viewed this item. Maybe they were comparison shopping between other lenses, but maybe they were looking at completely unrelated things, right? So it's interesting, but it's a lower score. Bought together is obviously is quite high. And here we're not using this, but this is also, yeah, like I said, the ones that were rated highly. So this is all discovery phase, but we build into this the concept of scoring automatically. So that's a taste of how Neo4j can do recommendations, and obviously do them in real time. All of this is calculated in real time based on what I click and what's in the graph, right? So if we chose something different than the lens, we might get different recommendations, right? So products with similar categories, we don't see lenses anymore. Now we see computers, right? So it's all being done in real time based on the context in the graph. And if that was being updated in real time with purchases and page views, then our recommendations could change in real time based on what we're seeing in real time. Okay, so we'll talk about one more use case. And this is supply chain management, right? So we're looking at a particular item, really. So we've got a particular item. It's UPC, which would be used as kind of the universal code from all the suppliers, and then here's our SKU, which would be our internal reference. So we can look at the different suppliers that we get that item from. Here we have 2, and then we get into a bit more detail on this supplier over here, right? So we can understand what shipping options might be available from that supplier. Can we get it quickly? Is it expensive? Have we had any previous shipment issues? So what events are related to the supplier? Even things like arguments over payment, or issues renewing contracts or whatever. And here we have the contract and service agreement information as well. What country is that supplier based in? Which of course you might have to take into account if new tariffs are coming in line, or if there are shipping problems or unrest in a particular country, how that might affect your ability to get the things you need, the products you need. And then, of course, again, market data. So what is the market saying about the supplier? Are they in good shape? Is it in your best interest to continue working with them? Or, should you maybe consider getting these from another supplier? And then, of course, crucially, of course, we know the cost from that supplier, right? So that's how we can start to calculate margin, use that to make our recommendations, and also to do some of our reporting. Here we see information about our organization, right? Our facilities. So that UPC is in inventory at this particular warehouse. It's also at this store location. We have some sale information about it. So how much is it sold at that particular location? How much is it likely to sell at that location? So that we can start to predict demand and how much we should order next, how much we should have in stock, or can we get it from the warehouse? And then again, there's some locality data about individual stores. So again, my example about the hurricanes on the East Coast, are there things going around locally around that store that might influence both your ability to get things and as well as how much you might need, right? So you can start using this additional data and this context on the graph to make decisions about where, when, and how much you buy from individual suppliers. So can you use the graph to help you improve your ordering and procurement process? Absolutely. Even just being able to have a view of all your suppliers and their relationships and the data about them and what they supply you, that in and of itself can sometimes be difficult to achieve across lots of different data sources, or where there might be different kinds of touch points, Excel files, or emails, or whatever. Can the graph help you save money on orders? Absolutely. So we have a lot of customers, not even just in retail, but more generally, who use Neo4j for supply chain management to help them, optimize their orders, being able to know when they have to buy in bulk, so they're not taking a siloed view of their need across different business lines or across different business entities, but instead having a holistic view of how much they need, all in one go, so that they can drive better bargains when they purchase individual things. Can you optimize your inventory using a graph? Absolutely. So when you have a view of your inventory, where it lives and how that matches against expected demand, then you can start to make decisions about how much inventory you should maintain, where that inventory should live. So being able to optimize not just your supply chain, but your own inventory, and where, being able to reduce your costs by carrying less inventory, by needing less facilities, if you can start to predict need versus demand, supply versus demand. And then, can the graph help you with comparative analysis of your suppliers and their products? Yes. So again, having that holistic view of all of your suppliers, understanding your terms, what issues you might have had with them in the past, cost, any geopolitical risk, then you can start comparing suppliers and making better decisions about which ones to work with in a particular case. So just briefly, some other use cases for graphs that might not just be retail specific, but may be applicable to your business. So identity and access management. This is understanding access rights, maybe not just for your customers, but especially internally, who can access what data, who can access what system, who needs what documentation, in multinational, multi-tiered organizations, identity and access management can be very complicated. So the graph can definitely help out there. Infrastructure and network management. So the graph is a very natural way of modeling infrastructure. So where your IT estate lives, how things are connected together, what applications and what data live on individual servers, and how do those things fit together? How does data flow around your system? Can be extremely valuable for large organizations with significant IT estates. Master and metadata management is being able to understand all of your data, how it's described, what your ontologies are, where it lives, how it fits together, what is your reference data and how does that fit together. All of this is a very good fit for the graph as well. And then, of course, regulatory compliance, especially when you're looking at customer 360 use cases and this sort of thing. GDPR, you need to understand how data flows between your systems. If someone chooses to be forgotten by your company, then you need to know where their data lives and how to delete it. You need to know all the data you have about them so that you can report to them if they ask for it. So the graph can power all of this, can really help you understand how data fits together across those silos, so that you don't have to go to 15 different system owners and ask them if they have some data about your customer. Because you know where that data lives and you have that map. And then it's important to understand, we've been talking about some very small example graphs, individual customers, very small slices of their data, for the ease of demoing, right? But really the power of all this is when your data looks like this, when you have really big data sets, lots of customers, lots of products, lots of transactions, and still being able to do the things we talked about and the things we saw in our recommendation demo at that scale in real time. And that's what Neo4j brings. Quickly to look at some case studies, real world production case studies for Neo4j. So first we have Walmart. Walmart uses Neo4j to power online recommendations. It can do this at scale, and of course with high availability, which is really important for these sorts of use cases, right? If your recommendation engine becomes unavailable, you can't make recommendations to your customers, then they'll have a poor experience. So your website might not render properly or look a mess. But also, you're missing a huge opportunity because recommendations do drive additional revenue. That's all wasted, wasted opportunity. Then there's another top tier US retailer who moved to Neo4j to really power its real-time promotions engine, right? And it does this across across channels, so both online and retail in sync, like I was talking about before. And really, they found Neo4j was the only way to be able to do this, right? You can see here, they have more than 35 million daily transactions. Each of them, the graph query is 3 to 22 hops, so 3 to 22 relationships long. And Neo4j does 90% of those in 4 milliseconds or less. So they've been able to run Cyber Monday or Black Friday, peak volumes, promotions online and in their traditional retail channels, real-time promotions using Neo4j, which is really exciting and a really good use case. And then finally, Wobi, which is maybe not a traditional retail company in the way we might think. It's a price comparison website. So they have used Neo4j to develop what they call whole customer understanding. So it's very similar to the customer 360 use case that we talked about. They take all the information they know about their customer, and this can even include kind of how much they're spending every month on a water bill or an electric bill. And then they can start making recommendations using their price comparison platform to individuals, right? So if they see that your electric bill has suddenly gone up, maybe they could find you a better tariff or a better offer with the company that you're with. So using that whole customer understanding and developing that customer 360 view to really drive what I think is quite innovative, right? Being able to make those sorts of really intelligent recommendations based on all the data they have.